Hello, welcome to our next session in SEM. Thus far in the course, we have been relying on a dataset that has been specifically prepared for SEM analysis. The set has been cleaned up and reorganized to make the analysis easier. The data you will collect will not be this pretty. In fact, it is likely that the SPSS file you will have will include errors, missing data, and other issues which need to be addressed before you attempt SEM analysis. This session will be useful for students who are collecting their own data and who are planning to carry out SEM analysis. The session will deal with all the problems that need to be resolved after you collected the data and before you can add it to your AMOS software for estimation. These include the question of accuracy of data, its coding, missing data, and some assumptions behind the methodology. In my treatment of those issues, I've split the topics in two parts. First part deals with all the problems that apply to any multivariate technique. The second part covers SEM and AMOS specific requirement. Other than the tips on preparing files for analysis, I will also talk about sample size and its effects on analysis. A little health warning may be warranted here. In the instructions that follow, I am mixing and matching formal procedures, that is, official guidelines on how things should be done, and my own rules of thumb, that is, my acquired unofficial wisdom that comes from having dealt with data for a while. I normally start from visually inspecting the file and specifically from a quick look at the Variable tab in SPSS. Sometimes, when you open data, the software does funny things with the setup of your variables. I always begin by checking whether the variable type is correct. For example, whether all my variables have been labeled as numeric as opposed to string or other. This matters because mistakes happen, and if your variable is labeled as string instead of numeric, the analysis will not run. So start from such inspection. Next, I run frequency analysis to see if there is anything suspicious in the answers to the questionnaire questions, and to check if I have any missing variables. I'm going to open my SPSS spreadsheet and go through the process. To do this, go to Menu Analysis, then Descriptive Statistics, then Frequencies. In Frequencies menu, change Properties Analysis to obtain descriptive statistics for all the variables. Go to Statistics menu and tick Mean, Standard Deviation, Minimum and Maximum. Then go to Chart Options and tick Histogram. This will give you a sense of any problems with the data in your spreadsheet and the first indication of any issues such as violations of normality. Go through all variables to correct them. Check if there are any out of range values, for example, whether the range of answers exceeds the options to your answers. For example, if you used scale from 1 to 7, any answers that are 0, 8 or any other number needs to be corrected. Your initial screening should check for conformance to other multivariate assumptions. For example, histograms combined with mean and standard deviation will show you if the data meets the normality assumptions. Normality refers to the shape of the data distribution and its correspondence with normal distribution. The shape can be described in terms of its kurtosis, flatness or peakness of the distribution, and skewness, that is the shift in the distribution to one side. Tabachnik et al. Provide a good guide to data transformations that may help you remedy excessive kurtosis and skewness. In my own experience, I rarely transform data, and the reason is threefold. Firstly, because I typically deal with very short scales, like Likert 7-point scales. My past experience of transformation has not been particularly successful. That is, I found that the transformed variables have not improved much. Secondly, I find that any problem variables will normally be picked up later in the analysis. For example, I often find that skewed variables do not work in the measurement model and that they have to be deleted anyway. Thirdly, the estimation techniques are said to handle non-normal variables pretty well, and the effect of non-normality may be negligible in larger size samples. Hare, for example, suggests that non-normality may be ignored if sample exceeds 200. Another issue in data screening involves outliers. Outliers are cases with unique combinations of characteristics that make them distinct and different from all the others. Typically, multivariate textbooks make a lot of fuss about outliers. I tend not to bother for two reasons. One, I tend to deal with Likert scales, anchored with 7 points, and such scales rarely produce outliers. They are simply too short. Secondly, Hare et al. Suggests that outliers should be retained unless you can demonstrate that they are not representative of the population you are researching. Such proof is difficult to come by. Let's pause briefly here before we go to the next tutorial, which concerns missing data.